This is the largest remote control submarine in the world.
A huge custom-made RC vehicle that works just like a real submarine, with working ballast tanks to control buoyancy and even a functional FPV camera periscope so it can see underwater. In this video you'll see how we built this giant RC submarine, going from small prototype all the way up to the nerve-wracking maiden voyage of the 2.7 metre long vessel. The previous biggest RC submarine was 2.4 metres long, but I wanted to see if we could build something bigger. So I got some materials together and started building. And the first thing we needed to do was start right at the beginning by building a prototype to make sure our submarine would work. But really, the very first thing to do was to understand the concept of buoyancy and how submarines control buoyancy to dive and surface. Now you might think that light things float, whereas heavy things, like these weights, sink. But buoyancy is a bit more complicated than this, as it's all to do with how much water the object displaces. For example, if we use this syringe with a bit of clay on the end to hold a load of air in here, we can put this in the water and you can see that that just about floats. But if we take this out of the water and compress the air, like this, using all of my strength, I can hold that in place with a bit of wood and then put it back in the tank, and we should see it now sinks. The syringe now weighs more than the water it displaces. Now we are going to use this principle using motorised syringes inside acrylic tubes, which will be the hull of our submarine, to make the submarine go up and down. The first problem to solve was to figure out how to get the syringes motorised, so that they could pull water in and out of the submarine to change its buoyancy. First I got a strip of wood and glued 2 small syringes to it. Next I found a length of threaded rod and fitted a small plate with a threaded insert so that it could be screwed onto the rod and attached to the syringe plungers, meaning when the rod turned, the syringes would go in and out. Next to add an adapter to the other end, and this was so that I could bolt a small high-torque motor to it. This motor turns very slowly but with a lot of force thanks to its gearbox. With the motor in place, I hoped that now we could make the syringes move in and out electronically when adding a small voltage to the motor.
Yeah, it works!
So the syringe system was working pretty well, but to have really fine control over the submarine, we'd need to know exactly what the positions of the syringes were at all times, so that they could bring in just the right amount of water. So for this reason, we gave the syringes positioning control, using an electronic component called a potentiometer, which was wired up to a servo control board to move the syringes just like a giant servo. So when this was all hooked up to RC control, moving a dial would tell the motor to keep turning until the requested position was sensed by the potentiometer. Right, now we had that bit sorted, all I needed to do to make this a proper proof of concept model was to chop up a bit of acrylic tube to make the hull of the submarine from, along with some 3D printed removable end caps. And now we had a really simple RC submarine that